Hey guys, welcome back to our channel. Today we are going to solve the majority element problem on Leetcode. So, what exactly is the majority element? Basically, it is an element that appears more than n by 2 times, where n is the length of our array. So, for example, consider this array 3, 2, 3. Here, the majority element is 3 because it is appearing more than n by 2 times, right? Consider this here 2, 2, and then again this 2, 2. So 4 times 2 is occurring and it is greater than the n by 2, which is the length of the array. So 2 is our majority element. So basically, we have to find the majority element and under the condition that it always exists in our array. Okay, so before we start writing up the code, let's try to find what can be the possible ways to solve this problem. So we are given this array that is 2, 2, 1, 1, 2, 2, right? And the length of the array is 6. So we have to find an element which is appearing 6 by 2 times, that is more than 3, right? So the most obvious or the brute force solution is check each and every element occurrence, right? So that means let's say our first element is 2, right? Now take 2 and check whole array how many times 2 is occurring. Now move to the next element. Again, check in the whole array how many times 2 is occurring and so on. So similarly, we can go to 1 and check all the occurrences of 1, right, in the whole array. And if any chance this is greater than n by 2, then we will return that answer, right? So basically, what we have to do is we have to loop through I 0 to n, right? And n, we know the length of the array, right? And now for each element I, we need to check whole array. So we'll run one more loop j till the n and check the count, right? And if count is, let's say this c is our count, and if this count is greater than n by 2, then we will return that element, right? Now talking about the space and time complexity, as we are doing a nested for loop 2 times, that means the time complexity should be of the order n square, right? And this n assuming the length of the array. And similarly, we are not using any extra space, so the space complexity should be of 1, right? So this is the most obvious and the brute force approach. That is, we can check each element in the whole array and get the count. And if the count is greater than n by 2, just simply return it, right? But as it is taking n square time, so there is a need to optimize it further. So in the previous solution or the brute force one, we have checked each element and its occurrences, right? But now, how we can optimize it? As we know, we are checking each element occurrence, right? And now, till now, after a lot of lectures, everybody should have understood whenever we talk about the occurrences, then the best way is to do the hashing. So in this also, we will do the hashing of the elements of the array. So what does that mean? That means we will store the count of that particular element, right? Let's say I have this hash table, right? And let's start from the first element, right? Now this is 2. We will check if 2 exists in the table. No. Then we will insert 2 and taking its count as 1 as we have uncounted it first. Now moving to the next element, again 2, and we can see this 2 already exists in the hash table. increase the count by 1. So it becomes 2. Now this 1, right? The next element. We will check, is 1 exist in our hash table? No. So we will add 1, right? Now moving to the next element, again 1, and we'll check if it exists in a hash table. Yes, it exists. Then we will increase the count of 1 by 1. That is, it becomes 2. Going to the next element, we will check this 2 exists in our hash table. Yes, it does. That means we can increase the count of the 2 and make it 3. Moving to the next element, again a 2. We will check if 2 exists in our hash table. Yes, it does. Then we will simply increase the count of 2 by 1, right? Now this hash table have all the elements and their count, right? So we can simply loop through this and check each count. If it is greater than n by 2, that is this 2 and 4 is greater than n by 2, then that means we got a majority element, and in this case this 2 occurrence is 4 and n is 6, so 4 is greater than, obviously that is 6 by 2 3, so we will return this 4, right? Now as we are using extra space here and looping through our array only once, so this time complexity, as we are using one single for loop, will be of n, right? And as we are using hash table or an extra space, and in worst case we need to store n elements in a hash table, so assuming the space complexity to be n, where n is the length of the array. So in this approach we have reduced the time complexity, but we have increased our space complexity because of hashing. Now let's see if we can optimize this solution further or not. Let's think about it. Now let's think of another solution or approach to find our majority element, right? And this approach or solution is that we can call it as it is given by a famous person, Moore. That is this. I'm not sure about the spelling, so you people please do check it out and maybe Google it. What is the spelling? But I think this is the correct spelling, and we can call it as Moore algorithm. Okay, so to understand this algo, we need to, let's first dry run this. Okay, then you will automatically understand the algo. So this algo says maintain an element and the count of it. Okay, so initially this count is 0 and this element has nothing, basically null as of now. Okay, let me make it clear that this is the 0. Okay, so let's start from the first element. Okay, this algo says if the count is 0, that means we can assign this element the current element. So this current element is 2, as we are starting from the array, so we can give 2 here. Okay, now and increase the count as 1. Okay, so now again coming to the next element, it is 2 again, but the count is not 0, so we don't need to replace this element. We can simply increase the count. Okay, now the next element is 1, right? Here, as this is not 2, that means we can decrease the count. Okay, we are only increasing the count if the current element is equal to EL. Otherwise, we will decrease the count. And if by any chance this count becomes 0, then we will assign the current element to this EL. Okay, that is the algo. Now again, going back to this first, as it is not equal to 2, we can reduce the count by 1 and make it 0, right? So till here the count becomes 0. So just see what does it mean. That means this 2, 2, 1, 1, right? It says we started from 2 and whenever we got 2, we increase, and whenever there is not the 2, we decreased. So it means if the count is 0, that means all 2's got cancelled out, right? All 2's cancel each other, right? That means this 2 is occurring half of the time of the other element. Let's say this array is 2, 2, 1, 1, right? Till here we have 4 elements, right? And if we see 2 is occurring twice, that is 2 times. That is half of 4, right? So that's why the count becomes 0. It says all the elements or the count got cancelled out by other elements, right? So that is the intuition of this algorithm. So basically the intuition is you start with the one element, and whenever you get the same element again increase the count, otherwise decrease the count. And again if you see the count is 0, that means that element is no more existing. It has done the calculation. We can move to the next element, right? So now count is 0 basically, and the current element is 2. Right, whenever the current element changes, we will change the EL and increase our count as 1. Right, again making it to the next element, that is 2, and increasing the count. Now we are done with the iteration. Okay, so if the count is greater than 0, then this algorithm says this EL has a chance of being a majority element if there is any majority element in the array. So it doesn't guarantee that EL will be a majority element if in the end count becomes 0, but it says if there is any majority element, then EL have a chance. But you have to check this out. Why I'm saying this? Let's assume instead of 2, right? Instead of 2, let's say we have 3 here. Okay, instead of 2 we have 3 here. Okay, now this EL, when we reach till here, right, this EL will become 3 and count will become 1 and 2, right? First it will become 1, then again the next 3 it is there, right? So it will become 2. So by this, we can see that count is greater than 0 and EL is 3. So it doesn't mean EL will be the majority element, right? It says it has a chances of being a majority element if there. That means after getting this EL value, we need to check whole array again and check the count of this EL. Then if the count of EL is more than n by 2, then we can say it is a majority element, right? That means if we treat this array, this let like this, we have this array, this 2, then 2, then 1, then again 1, then again 2, right? This 2. Now, as we got this EL as 2, right, in this array, that means we need to check whole array again, like iterate this whole array again and only count the 2's. That is 2 is coming, count it. 2 is there, count it. That is 2. This is 1, ignore. This is 1, ignore. Again 2, increase the count. Again 2, increase the count. So we got the count of 2 as 4. So basically Moore algorithm will not give you the exact majority element. It will give you the hint, that is this EL, which has a probability of being a majority element in this array. and we have to iterate the array again and check the count of this EL element. And this EL can also we can check only if this count in this algorithm results in more than 0. If this is 0, then we don't need to check. If this count is greater than 0, that is here 2, only then it says this EL has a chance of being the majority element in this array, right? So we will check this EL element occurrences. Here it is 4, that means it is a majority element as it is greater than n by 2, that is 3, right? So we can simply return this 4, right? As we are iterating through this array and we are not using nested loops, so the time complexity of this solution will be of n, and we are not using any extra space, we are just using a counter variable and the EL variable. So these are two constant spaces, so the space complexity of this algo will be of 1. So this is the most optimal solution of this problem by using the Moore algorithms. So hopefully you guys have understood all the approaches that we have discussed till now. Now we are back to our code editor. Let's start coding this. So before we start, let's see what we are given. We are given this nums array, and in the end we have to return the majority element, right? Again, I'm telling the question states there will always be the majority element. That means whatever the EL will come, we will take it. As the question itself saying, there is always a majority element and there is no doubt, right? So what we have to do first is check possible candidate of candidate of majority element by using Moore algo. Okay, so that we have to do. So Moore algo says declare an element EL and a count, okay, as 0. So it says look through your array, and that is I less than wait I less than nums dot length and then I plus plus. It says if count is 0, then take EL as your current element and increase count, right? Otherwise, if EL equal to your current element, right, then you have to increase your counter. And the third, it says if EL is not equal to your current element, right, that means you have to decrease your count. That's it, what this algorithm says. So we will implement this. That is, let's say if this count is 0, right, it says take your current element as EL, that is nums of I, right, and initialize your count by 1, right? Now this says if in a case this EL equals to your nums of I, that means you can increase your counter by 1. Otherwise, you can decrease your counter, right? So after this algo for loop or the algorithm, we can say that EL is possible only. First of all, we need to check if this count is greater than 0, then EL is possible candidate of majority element, right? But as this question says, right, but as we can assume that the majority element always exists in the array, it means EL should be our majority element, and we do not need to loop again to confirm, right? That means I have got my EL and I can simply return it because only as the question states, right? Now let me run this and see if there are any errors or it is fine. Yes, basic two test cases are passed. Now let's submit this solution and see. So we have passed and it has successfully been accepted. So hopefully you guys have understood what all the approaches and especially the Moore's algorithm to optimize this solution. And if you guys have any doubts, then please write down in the comment section. I will solve all your doubts. And if anybody, and I hope majority of you have understood what I am trying to tell you in all the approaches, then just say understood